Okay. Sorry about class on Wednesday. My wife finally made me go to the doctor. I've been having some stomach issues for like 2.5 weeks, and the boss finally intervened. But I'm fine. I'm on two antibiotics. I'll be back to normal in, I don't know, a week to 10 days, something. But I'm feeling much better. I don't think anybody from this class. I had some students from other classes. One student brought me soup. No, it was Noah brought me soup. V got me this giant stuffed animal that's in my office right now. I got a balloon from other students. I mean, I'm not really feeling the love from this class. That's what I'm kind of. I know it sucks grading this class too because there's so many assignments. All right. What's this? Yeah, I didn't feel sincere. Yeah, in hindsight, what I should have done is I should have done the class as a Zoom class. I just always forget that because we have a site license now for Zoom where, you could have all sat in your dorm rooms or whatever and just had class, and that's actually a really good tool. But, whatever, it is what it is. Hopefully you saw I put a video up of the solution to the homework, and I know it's a 15-minute video or something. So you at least had that, and then an introduction for the stuff you were going to need for today. So let's go through the homework for today. And I'm going to talk briefly about what you'll need for Monday. Monday is a little bit of a string formatting type thing. I would call it somewhat uninteresting, but it is what it is. So not really any new material, just kind of aligning things, but we'll talk about that assignment for a few minutes. And then I want to circle back to what we started talking about last week with, I guess Monday, with scoping rules. Remember, I was trying to show you why a variable shows up a certain way. I'm going to kind of reinforce that today because there still seems to be some misunderstanding about variable passing. So I'm going to kind of force the issue a little bit by making Python act a little bit more like most programming languages act. But let's dive in. Let's see, what do we use in here? Raspbian? Okay. And actually, let me just bring the book up in here. What's it called? Automate the boring stuff. Oh, perfect. All right, so homework for today was from what chapter? Chapter 5. And it was the video game thingy, right? Or the fantasy game, practicing with dictionaries. Then I actually did miss it. All right. So the idea is, this is kind of like a Dungeons and Dragons-y type thing. For all of this would have made a lot more sense to computer science nerds 25 years ago or something like that. Now we're all into the video games and maybe wouldn't necessarily think about it the same exact way. But I suppose if you most games anymore, you do have an inventory with your stuff. All right, but this is kind of going back to the days of something called a multi-user dungeon, a MUD, which is like a text, if you ever play like World of Warcraft or something like that, think text-based World of Warcraft, which seems boring, but I would say they're far more addicting than graphics, because in your imagination, graphics are always way better in your imagination than they are in whatever the video game can show. But in any case, the idea is that you might have an inventory in there that has some stuff, and we're supposed to create this function called display inventory that ultimately is going to output something that looks like this. All right, so it's going to take in an inventory as a parameter, and that inventory is going to be in dictionary format. Now, a dictionary, remember, is a collection of name-value pairs as opposed to a list, which is zero-based index. So we have something that lives at position 1 in the list, something that lives at position 2, 3, 4, 5, so on and so forth. A string is a collection of characters where there's something that lives at bucket 0, something that lives at bucket 1, bucket 2. So those are both zero-indexed collections, whereas dictionaries are actually indexed by a name. So it's a collection of name-value pairs. So this is stuff at position rope is equal to 1. Stuff at position torch is equal to 6, so on and so forth. All right, so this guy does not guarantee order. It doesn't guarantee that rope is first and torch is second and gold coin is third. Very well might end up being that way, but it doesn't guarantee that. It just has a collection of, they're called key value pairs. So it has a collection of keys like rope, torch, gold coin, dagger, arrow, and then values associated with each of those. Okay, so we're going to, they actually give you the starting point for this. So we're going to go ahead and implement this guy and work with our dictionary. And then I'm actually going to go down and we're going to, I'll do the second part here as well. This wasn't part of the assignment necessarily. I know some people did it, but we'll go through that as well. Go ahead.
Does the key necessarily have to be a string and a value to be an integer or float? Or maybe different things?
Key must be a string. Value can be anything. Yeah, key is always a string. Value can be, it could be a list. In fact, for your homework, actually, let's see, your homework for Monday, it's a list of lists, not a dictionary of lists. But yeah, value can be any Python value. But key is always a string. All right, so we're going to call this guy display inventory. At some point, I actually just need to reboot Raspbian because it doesn't like my I'm going to come back and do that again. We'll leave it up there. All right, so this is called display inventory. All right, and this guy is going to take, I'm going to actually name this something very specific. And again, I said I want to talk about scope some more today for where variables are accessible because there's still some confusion about passing stuff. So hopefully if we just keep hitting it from different angles, everybody will catch on. So we're going to call this guy our inventory dictionary. Okay. That's the kind of value this guy is expecting. A dictionary which represents our inventory items. Okay? Now, this is an untapped resource at this point. Somebody is going to have to call this function and pass me a dictionary of my inventory. All right, so this guy should work for displaying any character in the game's inventory. So if you have 100 players in the game and each one calls this function passing the dictionary of their inventory, it'll display their particular inventory. That's the purpose of functions, is to take in a generic input and give you an output based on what that input was, not hard coding stuff inside. So like you would not start off your code here by saying inventory dictionary is equal to, let's actually just create the dictionary here and show that it's, so I really wish I could copy and paste across here, but whatever. So rope 1, torch 6, gold coin 42, rope 1, torch 6, gold coin 42, dagger 1, arrow 12. All right, so something like that. So I've created an inventory thing there. Now, this would, I would say 99.9% of the time, if your code looks like this, you're going down a bad path. Because what we've done here is we've said, oh, I'm going to write a function called display inventory that's going to ask the user to pass us some inventory dictionary. And then I don't care what they sent me, I'm going to redefine it to something new. So now it'll print out that same inventory for every single person that ever calls this, because I've decided to just throw away whatever they've given me and just use my own. Okay, probably not what the intention is of a reusable function. Okay, this function takes in a dictionary and then displays some stuff. All right, so I'm going to put this later on in our program. I guess I could have just pressed enter on it a couple times. All right. So in any case, we're going to print out, I think what it just says, print out inventory first. So this is just displaying to the screen that we're about to show some inventory. And what they want us to do is they want us to go through every element of the dictionary, displaying it, but they also want us to keep track of the total number of items we've run into. So for instance, the output should be something like this, where it shows the number of elements, the value first, followed by the key. All right, but it added the 12 plus the 42 plus the 1, blah, 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 and got us to 62 here at the end. All right, so they gave us a starter code. So this guy, I'm going to show you a couple different versions of this loop. I think I actually showed it on that video, right? Didn't I do 3 different versions of the dictionary loop? Is that a true statement? Well, I'll probably bump into him today. One thing that I'm going to start harping on a little bit more with Python is Python's a very popular language, which is one of the main reasons why we use it as our first language. I'm frankly not necessarily a huge fan of Python as a programming language in the big picture, because they have too many little tools that do stupid things. So built into Python is like 4,000 little functions that accomplish something that could be accomplished otherwise very simply. So going through a dictionary, you can go through a dictionary 3 different ways. And let me just actually show that real quick, just to drive this point home. So let's say I'll just go outside of my function here. So here's my inventory dictionary. I can go ahead and I can say, well, I'm going to go through I'm going to name it key in inventory nailed it. All right, for key in inventory dictionary, and then I'll just go ahead and print out key, and we'll see what the output of this is. All right, and we see this shows me all of those keys: the rope, torch, gold coin, dagger. All right, so if I just go through this guy, it will give me the keys. That's what iterating through inventory dictionary gives me by default. If I also want to get the value, I can print out inventory dictionary at position key. Just like a list, just like a string. I would call this the most straightforward way of going through a dictionary. So now I'll get my keys and my values. Make sense? But there's some alternate approaches to this. If I want to go ahead and get my key and my value here, I could say key comma value, and then I can call items on my inventory dictionary, which will ultimately give me a bunch of tuples with key value pairs in them. So now, instead of saying printing out key, I can say I'm going to print out value. And I'll get the same ninja items. And I'll get the same output. Make sense? Those 2 for loops do identical things. Now, I personally don't think this is better. I would call something like this syntactic sugar, that allows you to do something in kind of a special Python-y way that might not necessarily line up to how we know collections work. We've talked about collections as being something we can index with those square brackets. My feeling is if you can deal with all collections in basically the same way, there's an advantage to that, rather than kind of treating dictionaries as this like one-off special case type thing. but Python has a lot of those things built into it. I'd encourage you to maybe steer clear of some of those things. It will benefit you when you start transitioning into other languages, because you'll get so used to the Python shortcuts that you'll have trouble kind of looping back to maybe a traditional way of doing things in another language, where you're like, oh, why doesn't Java have this Python shortcut built into it, when you could do it in Java the same way as you could have accomplished it in Python. All right. A third way we can do this is we can call enumerate on this, which is equivalent of calling items. That'll produce a collection of tuples. And that also gives us that output. That's just too many ways of going through a dictionary. All right? My suggestion is to use this version. For key in inventory dictionary, you can print out what this is, effectively the index value. You can print out all your indexes, and then you can also get the value at that index in the dictionary. I think this is the most compatible with programming as a tool, as a skill set, as opposed to programming as a Python programmer. All right, but pick your poison. Whatever you want to do is fine. Okay, so we're going to print out inventory here, and then I'm actually going to just go ahead and steal this code real quick and pop it up here. All right, so, and I'm going to actually rename this guy to LOL to really drive the point home that these two variables, while they will be synonyms for each other once we call our function, it does not have to be called the same thing. And we'll revisit that here in a few minutes. All right, so what are we supposed to do here? We're going to go through all of our inventory items, and for each one, we're going to print out the value followed by a space followed by the key. Okay, so inside of here, we're going to print out, here, I'll actually use the second one here. The value. Now the value, as he asked, can be any sort of animal. It doesn't have to be a string. So we want, if we're going to do concatenation, we're going to make sure that it's a string. So we'll take that string, we'll concatenate onto it a space, and we'll concatenate onto that whatever the key is, which has to be a string. All right. Now we also want to keep a running total of all of our items. So we might have a variable called item count, and we'll start that off at 0. And then inside here, we can say item count plus equals the value that was associated with our key. So that'll add the 12. It'll add the 42. It'll add the 1, so on and so forth. All right, so I'll print out the string representation of the value plus a space plus the key. Then I'll add the value, the numeric version of the value, onto my running total. And then after that for loop is ended, what's the string? Total number of items. It wants me to print total number of items. Now I'm actually show you a quick shortcut thing here that I do actually think is a valuable thing. Have you, in the book, I don't think you've read about F strings yet, have you? Doesn't sound like a thing. So we've been working with concatenation. We can certainly do that here. So we can say the total number of items, colon, and then concatenate that onto the string version of item count. And that should work. All right, so I'm just building up that guy. So now if I call display inventory down here, and I pass it LOL, okay, I pass it my local dictionary here, LOL will get passed in as inventory dictionary. This code is written in terms of inventory dictionary, not in terms of LOL, even though we know they're synonyms right now, because I can have a second dictionary called LOL2 that I want to also be able to pass to this guy and have him operate as inventory dictionary. All right, and there is our inventory: rope, torch, gold coin, dagger, so on and so forth. All right, now another way we could have written this last print statement. So we're going to print, and this guy's called an F string, which exists in Python 3, which is a formatted string. So this is going to be saying the total number of items. Actually, I probably should have said items here, but whatever. Space, and then you use curly braces here, and you say item count. And you see you get the exact same thing. So notice that this made it so that we didn't have to convert that guy to a string. Because we flagged this string here as a formatted string by just putting a little F before it, we're able to embed inside the string these little curly brace sections where we can say, I have a variable named item count, which is this guy right here. I want to go ahead and embed his value right here. And so as you start getting strings that maybe have more things concatenated together than just one, right now we're having a string and we're just tacking on a number. That's not the end of the world. But imagine if you had 10 pieces of information and you were having all this concatenate this, then concatenate this, then concatenate this, all this stuff. Things might get a little bit more tedious. All right, so these are two things associated with each other, and most programming languages have something like this formatted string. Even way back, the C programming language has something called printf that has a formatted string. So in C, it would have looked something like printf, the total number of items, %d, item count. It would have looked like that. That's from the late 1960s. Significantly, so the %d is a placeholder for a decimal value. All right, questions about that? I'll go ahead and leave both of our versions of print here in the example I'll post on Slack, just so you can look at it. You never have to use formatted strings if you never want to. All right, I'll never ask you to write code and say, you must use a formatted string for this. If you're just happy to go along doing normal concatenation and converting things to strings, if it makes sense to you, have at it. Nothing wrong with it. Okay, so then they wanted you to, another alternative to this, or a supporting function to this, might be that you have a list to dictionary function, which allows you to, let's see. So let's say you were just fighting a dragon, and you killed the dragon, as one does, and this is what the dragon dropped. You dropped a gold coin, a dagger, another gold coin, and a ruby. All right? And we want to add those things to our inventory. We can write a function here called add to inventory that takes in our existing inventory dictionary as well as a list of items that were just dropped. And we can incorporate those into our inventory. Make sense? So we've already looked at our previous inventory and we see that we already had some gold coins, right? So we used to have 42 gold coins. We would expect that to go up to 43 since we found some more gold coins here. Similarly, do we already have a dagger? I think we did. We already had one dagger, so now we should have two daggers, but we didn't have any rubies before, so we'll have a brand new thing in our inventory, ruby 1. Go ahead. Oh, right. What did I say?
You said 43.
Oh, thank you. Yeah, we'll have 45 gold coins. Okay, so we're going to go ahead and write add to inventory. So define add to inventory, and I'll use the same variable name here because variable names should be descriptive for what they mean. We expect to be passed a dictionary representation of our inventory, which inventory dictionary sounds like it's a pretty good description of that. All right. Then the next thing we should have is a list of items that were dropped. So we'll call this guy list of items from Dead Monster. Very, very descriptive. Assuming you killed a monster. We'll just say everything's a monster. If you want to be more very video gamey, we'll call it Dead Mob. Some mobile, whatever, Dead NPC, whatever. I like Dead Monster better. It's more fun. All right. So we killed a dragon, and we get a list of stuff the dragon had in it. That's what this guy is going to be, is that list of things that we're going to pass. And we want to incorporate the items that were found in there into our inventory dictionary. All right. So in order to do that, we're going to go through every element of this list. And we'll look at, for instance, gold coin. If gold coin is already in our dictionary, we want to add 1 to the count for gold coins that we already have. So we'll hit gold coin, that'll become a 43 for gold coins. We hit dagger. We already have a dagger, so dagger goes from 1 to 2. Another gold coin, now we're at 44. Another gold coin, now we're at 45. Then we hit ruby, and ruby is not currently in our dictionary, so we will add it to our dictionary and add 1 to it. Okay? Now, there is a default thing for dictionaries, but again, I'm not going to use the built-in thing. We're just going to ask the question. Remember, all programming languages provide facilities for remembering things, asking questions, and repetition. And if we can bring everything down to those levels, you can program in any language. All right? So we're going to write our loop that's going to go through every element of this list first. Okay, we're going to break it down to small problems. So I want to go through every single element of list of items. Okay, so we'll say for item in list of items from Dead Monster. All right, so each time through, item will be one of those items. In our example from back here, the first time through, item will be equal to gold coin. Next time it'll be dagger. Next time it'll be gold coin, then ruby. All right. Then we want to ask the question, is the current item already a member of our dictionary? And we can ask that question using this in keyword. This is a Boolean expression, so let's actually put this into our notes. In whatever, not in. In returns true when an element is in a collection. For example, 1 in 1, 2, 3 is true. 1 in 4, 5, 6 is false. Make sense? This allows you to ask whether something is a member of a collection. Similarly, not in returns true when an element is not in a collection. So if I just steal these two things here. It is false that 1 is not in 1, 2, 3. It is in there. it is true that 1 is not in 4, 5, 6. It's not in there, so it's true that it's not in there. Okay? So we have two different ways of, well, we have a couple of approaches to asking whether something is in a collection or whether something is not in a collection. So over here, we might be interested in asking if item, I like to use parentheses with my ifs, if item in inventory dictionary, if this item is already a key in there, then we would say inventory dictionary at position item plus equals 1. Add 1 to it. Else, if it's not already there, we would say inventory dictionary at position item is equal to 1. We have a brand new instance of that guy. So for instance, for Ruby, we would find that Ruby is not in our inventory dictionary. So we would get into this else here, and we would create a new entry in our dictionary for Ruby and set it equal to 1. But otherwise, we would find gold coin in there. So we would add 1 to our gold coin, add another one for the 3 gold coins from our example. All right, same thing for dagger, and if there was another one, whatever. All right, this makes sense? So we go through every item in our list. Each time we ask a question, if that item's already in our dictionary, add 1 to it. If it's not, add it to our dictionary and set its initial value to 1. Okay. So let's go ahead and we'll create our dragon loot. And dragon loot had what? Gold coin. And what was it? A dagger. We can just make it whatever we want. Gold coin, and ruby was the example. All right. So we'll go ahead and display our inventory originally. We've already seen that. Then we'll call add to inventory, passing it our original inventory, which we've, named LOL for a poor reason, but that's what we've named it. And then we want to add to that inventory our dragon loot. All right. Now notice here that inventory dictionary is never returned here. I'm modifying it inside here, but I don't return that value. I'm not coming down here and in the end saying return inventory dictionary. Dictionaries are passed by address. We talked about pointers on Monday. So if we think about a picture of our little world here, we have this, actually I'll be able to steal it from here, for example. So this is our dictionary that lives in memory. And we have a variable in our global scope named LOL that points at this dictionary. All right. That's this guy right here. LOL is equal to this dictionary. Now, when we call add to inventory and we pass LOL here, we get a new variable called inventory dictionary. That points to the exact same place in memory. They're both pointing to the same dictionary. So when I make changes to inventory dictionary, when I add 1 to gold coin, when I add 1 to dagger, when I add a ruby to this collection, those things are happening at this single location in memory. So that when that function ends and this variable is gone, LOL still points to that changed dictionary. I did not have to return it. It was changed in its permanent location in memory. Because when I passed it to that function, it was passed by the address to it. All right? If I give you the address to my house and you go to my house and spray paint my garage, when I get home, I'm going to find a spray painted garage, right? Because I didn't give you a copy of my house. I gave you where you can find my house in memory. So I know where my house is. Now you also know where my house is. And when you spray painted that garage, it's a permanent change to that garage. All right, make some sense? All right, so that's why we did not have to return inventory dictionary here, because when we made modifications to it, those modifications were permanently made. A lot of times, what this is called is side effect. When a value is passed by address, or sometimes it's called by reference, and it is changed, that change is permanent. Well, actually, it doesn't necessarily have to be permanent. We can undo it someplace else. So that change is noticed elsewhere in the program, i.e. it has side effect. When a value is passed by value, which means a copy is sent. So these would be all of our numbers, things like that. And it is changed. That change is not noticed elsewhere in the program. All right. So we'll go ahead and add our dragon loot to our inventory. And then we'll go ahead and display our inventory again, and we'll see that it did have side effect. It was changed. And now I have 45 gold coins. I have 2 daggers, and I've added a ruby to my inventory for a total of 67 items the second time through. Make sense? All right, so there is the code. Give you what we did today. Don't I have my Slack right there? All right, so there is that code. All right, now I want to talk about, let's see where we are in time. Let me talk about scope. I think you have what you need for the homework assignment already. You'll want to read through that chapter and see the couple of functions they introduced to you, but the homework's pretty self-explanatory. So I want to talk about scope. So scope is where a variable is visible. All right. Now, all Python programs, and actually all programs in any language for that matter, have something called the global scope. All right, well, that's, yeah, whatever. All right, so we have this global scope. Now, I'm going to shrink this down here. If we think about our code here, we have a function called display inventory, which has something called inventory dictionary in it. So display inventory has a variable in it called inventory dictionary. Our global scope here has LOL and dragon loot. Display inventory has that variable. We also created another variable in here called item count. Now, inside of this guy, we have a for loop. And that for loop has a variable in it called key. All right. Similarly, we have another function called add to inventory. That has an inventory dictionary and a list of items from Dead Monster. Okay. And then it has a for loop in it that has a variable called item. Each of these things are scopes. Anything found inside of this scope right here lives and dies with that scope. So we're only going to have access to this variable called inventory dictionary and item count for as long as this function is alive, is being called. As soon as it's done, any value that inventory dictionary used to hold, any item count is gone. So that's why the first time we called it, we had an item count of 62. The second time it started back off at 0. We got a brand new version of that variable that counted up to 67. All right. So these variables, inventory dictionary and item count, they belong specifically to this particular scope. Think of a scope like a room, right? If we put a couple of things into a room and shut the door, we don't have access to those things that are in that room when we're not in that room. All right? Similarly, over here in this other one, we had add to inventory, and this guy had inventory dictionary, list of items from Dead Monster. Those only exist when you're inside of this room, inside of this scope. Now, notice that each of these scopes also has another little thing, this for loop. For loops create their own little microscope. Microscope. So in this first for loop, he created a variable called key. Right here, for key in this guy. This variable key is only accessible as long as we're in that for loop. As soon as that for loop's over, if I were to try to print out key, it would print out none because Python allows you to have variables that don't have values, but it would not give me the last iteration through there because key no longer is accessible to me. All right, because it died when this for loop finished. Similarly, in this for loop, in the other one, we called our variable item. And it died when we fell out of that for loop. That make sense? Now, we saw last time that variables like LOL and Dragon Loot, they are available in these scopes because they're part of this more global scope. So these variables are available anywhere inside of the yellow box. All right? So this is 2 rooms inside of 1 big room. What I'm going to do starting next class is I'm actually going to create a third method that we're going to use in all of our things called main. So I'll create another method called main, and we will call that main method from everywhere else. And that's where we'll define LOL and Dragon Loot. That way, those things are only accessible inside of that main function. All right, so I'll show you that next time, but this is how scoping rules work. This is the explanation why you have access to these variables inside of these functions. It's kind of how Python programs are organized that allows you to get away with that. Don't leverage that. Just because you can see the value of LOL inside here doesn't mean you want to refer to it as LOL. You want to refer to whatever was passed in. All right, and we'll force that issue next time. Questions, comments, concerns, bribes? All right, I will see everybody Monday. For those of you traveling with the hackathon team to Illinois today, have a safe trip. I think they're going to Champaign, right?